Okay, good afternoon, and welcome to our event this afternoon, Fair Play and Technological Innovation. My name is Eric Hintz, and I'm the Acting Director of the Lemelson Center for the Study of Invention and Innovation at the Smithsonian's National Museum of American History. Welcome to everyone here in person and who's joining us online. I'd like to begin by thanking New America and their team for hosting us here at their really beautiful event space and for hosting the event online as well. I'd also like to thank the co-sponsors for this afternoon's event, which was a collaboration between New America's Future Tense Initiative, the Smithsonian's Lemelson Center for the Study of Invention and Innovation, and two groups at Arizona State University, the Great Game Lab and the Consortium for Science, Policy, and Outcomes. Thank you to everyone involved for making the event happen. Before we start the program, I have just a few quick housekeeping notes. The program is designed for all ages, and we thank you for engaging with our panelists and one another in a civil and respectful manner. The program is being recorded and will be available to watch on our co-sponsors' YouTube channels in just a few days. And of course, please check to make sure that your phones are silenced during the discussion. Please hold all questions until the end of the program. At the end of the panel discussion, there'll be a Q&A. We'll have some microphones available here at New America for audience questions. And our team will also monitor the Q&A in the online chat and bring some of those questions forward as well. So now let me tell you about the structure of this afternoon's program. The program will run for about 90 minutes. I will kick things off with a few remarks about our new book, Inventing for Sports, and then pass things off to Arthur Daemmrich, who will describe some of the policy and regulatory dimensions of disruptive sports technologies. Then Arthur will turn things over to our terrific panelists, Ginger Gottschall from New Balance, Jason Neubauer from Certor Sports, and our moderator, Victoria Jackson from ASU's Great Game Lab. Then the panelists will engage in a few minutes of discussion and audience Q&A, and we'll wrap up at about 5:30 p.m. Eastern, and then there'll be a post-event reception here until about 6:30 p.m. So, with that housekeeping behind us, let me begin the program with a couple of claims. First claim, every sport and every athlete rely on technology. That includes, if you think about it, highly engineered tennis rackets, snow skis, high-tech stadiums and the playing surfaces there, advanced shoes and apparel, Gatorade, high-speed photo finish cameras, et cetera, et cetera. So claim one, every sport and every athlete rely on technology. Second claim, it feels like the pace of technological innovation in sports is accelerating. So what do I mean by that? It seems like every few weeks there's another fascinating story in the news about the impact of disruptive sports technologies. Take baseball, for example. So earlier this year, during spring training, just a few months ago, Major League Baseball introduced an automated ball strike system powered by Hawkeye's ball tracking technology. Now, right now, it's set up as a challenge system, so the pitcher, the catcher, the hitter can challenge the home plate umpire's call with Hawkeye as the final arbiter. But it's pretty easy to imagine a future day where we might have fully automated baseball umpiring. So that's interesting. Now, the empirical data seems to affirm this second claim that we think that maybe the pace of technological innovation in sports is accelerating. I got a graph here. It's a graph of U.S. sports equipment patents issued from 1900 to 2023. And you can see here with this kind of classic hockey stick graph, a rapid increase in the number of sports technology patents issued between, sort of beginning in the late 80s, you see an uptick, and then a particularly noticeable spike starting around 2015. The dip at the end of the graph in the 2020s represents a slowdown due to COVID-19, but the long-term trend is pretty clear. The pace of technological innovation in sports does seem to be accelerating, at least by this one measure of patents. And more importantly, these disruptive technologies are challenging certain long-held traditions and spurring debates about fairness, safety, and other impacts in sports. We've been engaging in some of these debates at the Smithsonian's National Museum of American History. In March 2024, we opened a new exhibition called Change Your Game, Cambia tu Juego, that explores the dynamic role of invention and technology in sports. The bilingual exhibition showcases approximately 60 sports technology artifacts and highlights the motivations and practices of inventors who have developed advanced swimsuits, adaptive sports wheelchairs, protective helmets, instant replay, the jog bra, and many, many other sports technologies. Then, more recently, in February 2025, Arthur Daemmrich and I, and the exhibition's curators, Jeffrey Brody, Meg Marr, Jane Rogers, and Monica Smith, published a companion book to the exhibition called Inventing for Sports. The book enables us to dive more deeply into some of the stories we shared in the exhibition, and as Arthur will demonstrate, engage more fully with some of the policy and governance debates spurred by these disruptive technologies. The book is available as a free open access download, and we invite you to visit this link here behind the QR code and check it out. So let me just give you a brief preview of some of the themes we'll be talking about here. Both the exhibition and the book ask kind of two questions: who invents for sports and why? As Ginger and Jason will describe shortly, corporate engineers and product designers at firms like New Balance and Surtour Sports are certainly major drivers of innovation in the $143 billion global sports industry. However, we also find that many sports inventors are athletes who turn to invention out of frustration. Time and again, we observed that athletes become frustrated and become motivated to invent solutions when they lose a contest, sustain an injury, or endure a bad call. Athletes with disabilities and different body types likewise invent sports-specific apparel, prostheses, and wheelchairs when they are unable to participate fully in their chosen sport. Athletes also invent just to have fun and try something new. So in short, we found that athlete inventors are driven to develop sports technologies because of four primary motivations. One, to improve performance and gain a competitive edge. Two, to prevent injuries and enhance health and safety. Three, to improve fairness and accuracy through better officiating. And four, to make sports more fun and inclusive for everyone. So let me share really quickly 3 brief stories from the exhibition and the book that demonstrate some of these motivations. Okay, Marilyn Hamilton was born in 1949, grew up in California as a self-described adrenaline junkie. She loved water skiing, hang gliding, and racing go-karts. In 1978, Hamilton suffered a crash landing while hang gliding that left her paralyzed from the waist down. She was determined to continue her active athletic lifestyle, but soon grew frustrated trying to play sports in a standard hospital wheelchair, which was heavy and not very maneuverable. So Hamilton reached out to 2 friends shown here who were hang glider designers, Don Hellman and James Okamoto, and they collaborated on inventing an easy-to-maneuver wheelchair made with the same lightweight aluminum tubing and components used in hang gliders. And the resulting Quickie wheelchair has revolutionized wheelchair sports. It emerged from Hamilton's desire to be more competitive, yes, but it's also enabled people with disabilities to have more fun participating in sports. Okay. Sean Springs. So some local folks here may recognize this sports inventor. Springs grew up playing football at Springbrook High School nearby in Silver Spring, Maryland. He was an All-American at Ohio State University, then played in the National Football League for the Seattle Seahawks, Washington Commanders, New England Patriots. In 2012, after he had retired from the game, Springs was kind of searching around trying to figure out what his second career act was going to be when his family survived a horrible automobile accident. Springs became very interested in the airbags and the child safety seats that enabled him and his young sons to walk away from the crash uninjured. Like many football players, Springs suffered some big hits and concussion symptoms during his playing career. Motivated to improve the health and safety of the game, Springs decided to apply some of the same approaches from automobile safety equipment to improve football helmets. Springs founded a startup company called WindPact and invented what he calls crash cloud technology. Placed inside the helmet, these foam pads compress upon impact and redistribute energy through tiny air vents. WindPact crash cloud pads are now used in helmets for many different sports and also in military, construction, and automotive industries. Finally, last case, and then I'll get out of here. Paul Hawkins grew up in England and conceived the Hawkeye ball tracking system in the late 1990s after fuming over a bad call. During a cricket match, an official called him out after determining that the ball hit his leg but otherwise would have hit the wicket. Now, this is a judgment call, a subjective call. Drawing on his experience in computer science, Hawkins realized a system of high-speed cameras could track the ball's flight and velocity, then a software algorithm could use that data to predict the ball's likely future path. When a ball hit the cricket batter's leg, his imagined system could determine, based on the ball's predicted trajectory, if it otherwise would have hit the wicket unimpeded. So today, Hawkeye helps officiate 20 sports worldwide, including making line calls in tennis, shown here, goal line replays in soccer, and as I mentioned before, helping to automate ball strike calls in baseball. Hawkins was motivated to improve the fairness and accuracy of cricket and many other sports by using Hawkeye to improve officiating. So let me stop there, and I'll turn it over here in just a second to Arthur. Now, my brief examples might make it seem as if all new sports technologies are readily and seamlessly adopted. That's not the case. In fact, new sports innovations almost by definition tend to disrupt established norms and traditions, often stirring passionate debates among athletes, fans, and the media. And to address some of those underlying governance and regulatory issues, it's now my pleasure to welcome Arthur Daemmrich to the stage. Arthur is the director of the Consortium for Science, Policy, and Outcomes based at Arizona State University's campus here in DC. And Arthur, I invite you to take it away.
Thank you, Eric, and thank you all for coming. It's great to see you, some old and new friends. So the issue of technological doping emerged in the early 2000s, right on that curve that Eric showed earlier around the kind of accelerating change of sports patenting and sports invention overall. The World Anti-Doping Agency first used the term in 2006, but in invoking that, of course, also invokes a regulatory regime that had developed that went around kind of tracking athletes, collecting body fluids, determining whether or not they had inappropriately doped. But when it came to technological doping, the anti-doping agency basically said the individual sports bodies, it's up to you. And what's interesting, if you think about it, the trajectory of those sports bodies is many of them come out of 19th century sport and fundamentally existed to do two things. They exist to attract young people to the sport and to manage large events. Determine what 100 meters is and that it's the same everywhere around the world. So they're in that kind of standardization. They're not good at managing new technology introductions. That hasn't historically been their role. And likewise, we faced at the same time, over the last 2 decades now, I would say, a set of rising concerns that technology overshadows athletes' skills. So that competition will be technology versus technology. There are some areas where we enjoy watching that, right? The robot wars. There's people who are into that. But when it comes to an awful lot of sports, people tune in to watch athletic performance, not to see gear competing against gear. There's a set of health and safety risks that accompany it. So as you increase competitiveness, you also increase risk. The football helmet's a classic example. So the original leather helmets kind of protecting against abrasion wounds. The polycarbonate helmets protecting your ears and eyes and nose. But now as you introduce each of those helmets, the play gets more intense. So then how do you manage that? You kind of get in this acceleration wave of new technology versus changes in the sport. You also have a set of concerns about unfair advantage. And you'll see that momentarily around the swimsuit, that one country, when it comes to Olympics, or one team gets access to a technology before others. And that's kind of inherently unfair if you think about it. And then, of course, there's this much more nuanced issue about sports tradition. Sports relies both on written and unwritten rules, and new technology can really interrupt that mix. And so what we see is that a set of leagues that existed to basically promote sport, attract youth, and manage events got thrust into the role of regulation, which was in many times quite uncomfortable. And so a couple of case studies of this point, and then we'll turn over to our panel. So the use of prostheses in sports fundamentally dates to the post-World War II era, and we saw first wheelchair competitions for veterans out of World War II, the evolution into the Paralympics movement, and then the increasing ability of new prosthetics thanks to new materials to really make athletes quite competitive, in fact, even with people who don't have physical disabilities. So Van Phillips, inventor here, had suffered a horrible water skiing accident that led to an amputation of one leg, and then wanted to run and just jog. And all the prostheses of the time were wood or other materials. They were either too stiff and transferred all the shocks up to the leg and caused damage, or shattered. And so he then started, without an engineering degree, really started getting into this, finding different materials. He observed how cheetahs run, how animals run, and sort of looked at how the leg absorbs shock in those, and then began to develop this sea leg, also known as the cheetah prostheses. There's this famous video of him where he's, running down, he remembers running down a hallway saying, "Look at me, I'm running." I mean, just this breakthrough moment, right? So that brings us to a more complicated case when Oscar Pistorius, a dual leg, who was born with a congenital deformity and had both legs amputated as a youth already, so begins running and then competing with the prostheses. And he really rapidly in the early 2000s wins a sequence of Paralympic medals in the 100-meter and 200-meter at the Athens Paralympics in 2004. And then his times really are getting within split seconds of what people sometimes term as able-bodied athletes. And so then the question comes, why not cross over? And as an athlete, the difference in compensation and recognition of Paralympics versus, the other Olympics, the more famous one, is quite significant. So there's a huge incentive and motivation to do this. So he basically asked to do so. The Athletics Federation in 2007 bans any sort of spring-like device. So previously, again, this is an organization that's setting rules for competition in terms of the distance and who competes. So men compete against men, women compete against women. Now suddenly they're evaluating a piece of technology, and is this equivalent or not equivalent to the human leg? So they do a series of laboratory tests and determine that as you're in a full-length sprint, the sea leg provides some advantage over the leg. So they ban it. Pistorius then funds and carries out a whole nother set of laboratory testing, and they determine that at the starting gate off the block, you're at a significant disadvantage. So now you have a very interesting regulatory situation. Those of us who study regulatory science are familiar with this, but the IAAF was not. They take it to the Court of Arbitration for Sport, which overturns the ban, allowing Pistorius to compete in 2000. The act passes 2008. In 2012, he then competes in the London Olympics. He does not medal, but he does at least kind of set the precedent that this is possible. He, of course, is not really anyone's favorite role model for development subsequent, but a breakthrough I did want to invoke. This leaves a situation today where athletes with disabilities have to prove that they don't have an advantage over people without disabilities. And it's not that there's manufacturers backing this, it's really the athlete themselves has to fund the testing and document it in order to compete. And so the burden of proof is really, in a way, perhaps misplaced here or poses a challenge. So we want to raise that as an issue for discussion. Our second case study is the full-body swimsuit. So competitive swimming is one of the oldest sports, dates to the 19th century. And part of every Olympics since the kind of reintroduction of the modern Olympics. The history of swimsuits in competitive swimming, interestingly, is one of getting smaller for most of the history. So in the 19th century, people are wearing swimsuits made of wool and cotton. They cover quite a bit of the body out of modesty. You may have seen, photos of Victorians at the beach, and they're really wearing quite a bit more than anyone does today. And interesting then, in the 1990s, Speedo begins sponsoring a set of research. They work with NASA in the US, and they develop and begin to roll out a new generation of swimsuits, with innovations coming really every 2 to 3 years in quite a fast sequence. 2000 to 2004, they have the fast skin and then shark skin swimsuit. And so they're building like little quasi-scales into the swimsuit intended to help you glide. With generally quite minimal regulations. So the authority, FINA, really begins setting rules at this time around how far a swimmer is allowed to swim underwater from the launch, from the kickoff, but otherwise isn't really trying to manage the suits. And then we get the breakthrough of Michael Phelps. So 2008, the laser racer debuts. People wearing that suit set 130 records in the space of 2 years. The athletes and media begin to raise concerns. Phelps initially defends the suit, says it's about the swimmer, not the suit. But then when Paul Biedermann from Germany cuts 4 seconds from his 200-meter freestyle time in less than a year, Phelps also says we have a problem here. FINA then bans the suits that aid speed, buoyancy, or endurance, and men's suits now can't go above the waist or below the knee, and women's cannot extend past the shoulder or below the knee. So now swimsuits go through strict material testing and performance reviews. But there's really quite a rocky road to this balanced regulatory success, and the pathway there was very ambiguous both to the athletes and to the manufacturers. So my third case is regarding sort of open access and e-bikes. So e-bikes come online in the 2010s. And they appear a little bit out of nowhere when it comes to off-road biking. They've been a little bit in development, but then they're really like noticeably visible and available. And it challenges a set of issues because mountain bikers in the course of the 70s and 80s had done a lot of work in a kind of tacit way to negotiate access to trails. Horseback riders hated mountain bikers. I used to mountain bike. We had this whole negotiation outside of Philly about which trails to use, how not to scare the horses, how to balance hiker use, horse use, and bike use on trails. Out west, of course, a vast majority of the property is federal lands. And so interestingly, there's this surge of concern that damage to trails from these bikes is going to end up with all bikes banned by the Department of Interior. 2019, the Department of Interior basically sets a rule that allows e-bikes on trails for human-powered bikes and then opens up a rulemaking process. They get 17,000 public comments. So there's quite a bit of enthusiasm around this on both sides. They then go through a whole process and ultimately decide e-bikes are not non-motorized. That's a pure regulatory term if there ever was one, right? So they are human-powered, but they're also not motorized. Like, they're not sure what they are. And they basically say each local community, the government official, should work with the community to determine access rules. And so it's a striking decision because we actually get a local flexibility that we often call for out of the federal government out of this one case. It also results in the U.S. Forest Service having a different rule than other parts of Department of Interior. So depending where you go, you may or may not be able to use your e-bike. So what do we conclude from this? The sports governing bodies lack a kind of clear, transparent, and procedural approach to dealing with new technology that we would encourage them to now develop because they have been thrust into the role of acting as regulators. The sports tech firms are in a quite awkward position. They invest in innovation, they work with the athletes, but they also have to work with the leagues. And their core business model, of course, relies on elite athletes wearing their brand and everyday weekend warriors actually buying it, because you can't just sell it to the elite athletes, right? You need that everyday consumer. And so they have to find that balance. Okay, so to address where performance, safety, and participation are going, we now have a wonderful panel discussion. And I'm pleased to introduce Victoria Jackson, co-director of the new ASU Great Game Lab, sports historian, and professor in the ASU School of Historical, Philosophical, and Religious Studies. And not coincidentally, she's a competitive runner, including holding Pac-10 and NCAA national championship wins. Victoria.
Is this working?
Yes.
Okay, awesome. I did not know my athletic accolades were going to be included in my bio, so thanks, Arthur. And thank you both for presenting about the book and the exhibit, and then also taking us over to the exhibit today. It was wonderful. But I'm not here to tap dance and entertain you. You're here to learn from our two amazing panelists who are joining us from both coasts, Boston and Seattle. So please welcome to the stage Dr. Ginger Gottschall, Director of Sports Research at New Balance, and Jason Neubauer, Chief Innovation Officer at Searcher Sports and VP of Product Development with Vices. It's a soft C. Thank you. So we'll be chatting for about 40 minutes or so, and then please think of questions that you'd like to ask our panelists, and then also Arthur and Eric, who will come back up on stage to answer any questions you have about any part of the program or anything else related to sports and innovative technology. And folks in Zoom, you can type those questions into the Q&A function, and we're looking at that too. So thanks a lot. So as Arthur had mentioned, I'm at Arizona State University, and we, over the past 10 years or so, have made a pretty great effort to identify and bring together all the people who are interested in sport, either directly or indirectly, and across all of our disciplines. And I'm in history, right? And a lot of the humanities people, you don't necessarily think of sport being a subject that people in the humanities might take on as a disciplinary focus within the field. And so what we often do when we have newbies who join our collective of sports people is we have them share their story of how they discovered that sport could be something of serious inquiry and interest. And so, Ginger, I want to start with you. What's your origin story? How did you discover sport could be a space of scientific inquiry and also a means into kind of looking at questions of human performance?
My story is a little bit embarrassing, so let me get on with it. I was an undergrad at the University of Colorado Boulder. They had a triathlon team that they were thinking could get to be NCAA, so we were very serious. And I continually wondered how and why it was so hard to run after you rode the bike. Why is it so much harder than if you just went for a run of that duration? So I got some of my friends, took a trainer to the University of Colorado Boulder outdoor track, and I got $300 for a grant to study this, and that's not a lot of money to study biomechanics and physiology. So I bought a ton of baking flour, and I spread it on the track. They rode their bike, they got off their bike, and ran and would step in the flour. I would quickly measure the distance between their steps, count the number of steps, get their speed, and have this great scientific experiment until participant number 8 came and it snowed in October and it caked the flour to the NCAA track. No problem, because by the time March rolls around, there'll be so much snow, it will just have disintegrated that. No problem. Well, that wasn't the case, and I got a call from the athletic director saying if I wanted to graduate, I would be removing the flour from the track. I had a very kind friend, and I bought, with the rest of that money, about 33 extension cords that I ran into the locker room and a Mighty Duck carpet cleaner. Took that flour right off. But I think what it showed me is I am dedicated to science. I absolutely will find the answer to that question, and I do feel if you look at my career, which is now 25 years plus, even if I have to do something extremely creative with rubber bands or some sort of slime, I'll get the answer for you. So there I am. And now I'm at a very different place, by the way.
Thanks, Ginger. Jason, does your finding of sports story involve flour or slime or anything like that?
No, neither of them. No, it doesn't.
How about you? What's your story? How did you discover this as a space?
Yeah, so growing up on the water and doing a lot of what you might call more outdoor sports, whether it be sailing or windsurfing, water skiing and snow skiing, all sports that are really involved in gear. And gear makes those sports interesting, but also allows you to do new and interesting things. As mountain bikes become larger travel, you can go down steeper hills, and as they invent hydrofoils that can go on the bottom of surfboards, now you can ride waves out in the middle of the ocean. So I was just really attracted to these sports that happen to also be very much gear functioned products. So when I got into university and was able to actually look at a career where during the week I could work on something that I could use on the weekend, that was a dream for me. And so, and it turned out I was something decently good at. And so that's how I kind of got started.
And that like tinkerer eye,
Yeah.
is it always on?
For sure.
Are we going to be subject to the tinkering? Like
Whenever you're
wherever you
driving,
are?
whatever you're doing, you're always thinking about. That's how sometimes you forget where you're going.
Ginger, the lab at New Balance that you run, I imagine there isn't a typical day and that you've got a lot of different projects running because you work on a lot of different sports as well. So we know there isn't a typical day, but what are some of the projects and the general work that you're doing with your team?
Well, let me describe a little bit about the sports research lab in Boston. Is Jim Davis, who is the owner of New Balance, it's still a family-owned private company, had a dream of having a place where athletes would want to come and get tested and be a part of the creative process. And that is exactly what he has developed. It's a 50,000 square foot facility with a huge run lab itself, but then plus half a tennis court, half a basketball court, and a full turf to actually run studies and get athletes in the space doing what they do best and in the environments where they're most comfortable. So my job is facilitating three things. One is called Athlete Insights, which is learning about our professional athletes as well as community athletes and their needs. The second is actually really unique. It's called foundational research. Doesn't have to have anything to do with product. It's just how can we keep people moving with a smile and for as long as possible. And the third is called innovation. That's our largest, as you can imagine, component or team in my group. And for us, it's all about what can we do that's cutting edge. And I'll tell you, working with world athletics, especially in track and field, that's very difficult. The rules are extremely strict. But it's fun to still work within guidelines and to see what we can do with both materials as well as technologies in terms of aiding performance and making it still about the athlete.
Am I right in thinking that you all have like a show and tell day semi-regularly where people bring stuff out? Is there something super cool that you can share with us, that, if this is true?
Yes,
that's
we
been
have.
shared?
If you go on what's our regular weekday, there's only two things that happen every week, and that's Monday operations meeting. I missed it today, I'm sorry. And Friday, which is called Knowledge Share, which in my group of 12, you can sign up for a Friday time slot. It's for 90 minutes, and you just bring anything to the table that you've been working on, a crazy idea that you've had, prototypes that you've hacked. And actually, one just from this week is I have had something in my head about trying to help people who pronate and run. And super shoes these days are really squishy. And if you pronate, it's difficult then to roll back onto the mid part of your foot and actually push off. So I helped with a designer and another engineer to create a prototype shoe for pronators. It is the most uncomfortable thing you've ever worn in your life. It's terrible. But another engineer, Emma, had an idea about how to modify my prototype and still assist pronators by just doing some cool hacks in the midsole to take away some of the pressure in the heel, but to help you roll forward. So that was fun, and I felt my heart warm that she took my failure and may have made it a success.
Well, the pronators in the room are super pumped to hear about this, myself included. Jason, so your background in outdoor, adventure, extreme sports, not a football player. I don't know, these days, kicker maybe, wide receiver.
No, definitely never played football.
So how did you find your way to working primarily on football equipment? And I know Searchor does other, sports as well and equipment in other sports, but how did you end up there? And share with us how designing football helmets is different from designing helmets for most other uses as well, please.
Got it. Yeah, so when I was developing other sporting goods products, I've also been doing that for about 25 years. I had the opportunity, someone came to lead a group that was a spinoff out of University of Washington that was this brand called Visus that was looking to make a difference in football helmets as far as just kind of maybe look outside of the box is maybe the right way to look at that. And like not being a football player or a huge football fan, it was an engineering interest of mine because the challenge was definitely there. And this was during a lot of the time when there was a lot of interest into head health within sports. So I took the challenge, and it definitely has been a challenge throughout that time. And so that's kind of how I got into it, was leading a group that took on the challenge of making something that was truly unique as far as looking at the brain health or the head health of athletes that are really going at speeds that can be very dangerous, and how can we minimize that risk for them?
How do you balance safety and aesthetics? So, like, how do you sell that to somebody? Like, if a football player is like, that makes me look like a total dweeb, I'm not wearing that. How do you sell? And then what does that dance look like in design?
I mean, that's a design for all sporting goods, or particularly for all safety products, and no matter what it is. At one time, it's always that you can only protect someone with a product that they actually are willing to use. A good example is at one point I was designing ice axes for an outdoor company, and all ice axes will fail at a certain pry rate, which seems super dangerous, and someone might die from that. But if you make them ultimately stiff and ultimately strong, they'll be too heavy and no one will actually go out and save themselves with them. So you have to blend that rule of like, how light can I make it and still strong enough to protect them? And the same thing goes for football helmets. We have professional players come into our office all the time to try or maybe get fit for a custom helmet. And you'd be surprised that everyone that comes in, the first thing they do when they put the helmet on is not ask questions about the comfort or whatever. They say, where's the bathroom? And because the first thing you want to do is go look in the mirror. So we very quickly had to mount a mirror in our office so they didn't have to keep going back to our bathroom to look at themselves in the mirror. But that's, what an 18-year-old who thinks he's indestructible worries about the most is, how do I look? And for each player, that might be different. Do I look fast? Do I look mean? Do I look aggressive? Whatever they want to look like is important. And so, and again, you can't protect them if they don't think they look good. And, we've definitely learned that the hard way. There are some athletes that are very, very focused in their future health, and they'll read up and they don't care what they look like. But I would say that's by far the minority.
As a high school basketball player that never wanted to wear my mouth guard, I hear that very much. So it's cool that you guys think about that when you're developing and designing product too. Ginger, let's talk super shoes, because I feel like if there's any runner or someone who follows track and field and running in the room, they're going to have many questions about the super shoe kind of disruption. I think that's appropriate to call it that. Not unlike what we saw with the swimsuits, thanks to the presentation earlier today. So, I should also share, there's an opportunity to watch another kind of Nike spectacle performance this summer, which is going to be super exciting. So the super shoe technology Ginger is going to explain, because I'm not going to be able to do that. But you might have seen a big push, more than half a century ago, we had this big question: is it humanly possible to break 4 minutes in the mile? And so we got the answer to that. Now hundreds of people are doing it annually. And more recently, the question was, could a marathon runner break 2 hours in the marathon? And so Nike, on like a Formula One racetrack with like pace lights and all these kind of technological enhancements, so it's not record eligible, set up Eliud Kipchoge, one of their wonderful personality and very fast athletes, and he successfully broke 2 hours in the marathon. And what I'm telling you to look for is that Faith Kipyegon, who is also beloved, will be attempting to become the first woman to break 4 minutes in the mile. And so there's going to be a whole campaign, and you'll be able to watch the stream, and there will be a documentary around it and all of that too. And she is beloved by the middle distance global running community. And so the Super Shoe has rewritten the record books across not all but most events. So not quite as dramatic as what we saw with the swimsuit intervention, and introduced now almost a decade ago, but improvements even in that short span of a 10-year period. So Ginger, please share with us all about the Super Shoe technology, and then I'll have some follow-up questions too.
Perfect. In 2018, the scientific research article was published about the Super Shoe that gave us the actual data to understand what the improvements were. And I'm going to tell you the percentage, and it's not going to sound like a lot, 4%. 4% improvement in economy. Now, that can lead to a 10-minute improvement in your marathon time. So that becomes very significant, and absolutely the difference between podiums and money in the professional ranks. The shoe itself, there's basically 4 things you can change about a shoe, and the first thing is mass. So the shoe was incredibly light. The second thing is the shape. The shape of the shoe was much more like a boat. So it had both a kick at the heel as well as the forefoot at the front. You can change the midsole, and these shoes are extremely thick in terms of their stack height, so they're quite high. There's now a regulation that it can be 40 millimeters, and so most companies take that to the absolute max. And then you can change if the shoe has a carbon plate or not. And the carbon plate, we actually don't actually understand the entirety of the mechanism, but it's thought that perhaps it's going to help with that pushing off the ground, and it's going to help stiffen up the front of your foot so you can get a better push off. The Nike Vaporfly 4% did all those things in one and just threw everyone off balance and made that difference. Some runners, it's 8%. But actually, some runners, it's less than. It's actually a detriment. So we're still not totally understanding a super shoe, which is maybe one reason why it hasn't gone to the extreme of the swimsuit, because not everyone is getting faster from them. Now, the 4-minute effort's a little different because we're talking about a spike. Spikes can actually be half of the stack height, so you're working with a lot less. And world regulations have a whole bunch of different rules with respect to the carbon plates and how they can be oriented. So you're actually left with a lot less to play around with. As you can imagine, being from a competitor brand, we are on the edge of our seats to see what this new spike is. We've seen some pictures and heard some rumblings, and the spike is probably not going to be what does it for her. I don't mean to ruin it for everybody. What does the difference in something like that probably is more related to drafting. That is also a technological advancement, though, because now we have the computer modeling to understand where exactly every single draft runner should be for her with her body mass, with her frontal area, with the speed that she's going to run, the surface that she's going to be on. I mean, think of the details that has gone into this computer model. So it's still innovation. It's still an incredible accomplishment from a human being standpoint. It's not going to be the shoe. So check out the drafting. You even get a little bit of push by having somebody in back of you. So we're interested to see on what that's going to be like.
Okay, amazing. So I feel like carbon fiber is something most people have a familiarity with and being introduced in other sports products, not necessarily shoes. And I always think of it as being like a propulsive effect, but maybe that's an exaggeration. And then the other funny thing about the super shoe was that it was introduced kind of in a moment of minimalism in shoes. Like, do you remember the whole like barefoot running fad? And then you had the exact maximalist, like opposite intervention. And it's counterintuitive because those things are almost weightless. They're so lightweight. So the materials, technological improvements and that foam, and then with the carbon fiber, that combination is just wild.
It is very wild. And I will tell you, of those 4 characteristics that I mentioned, every single one of us in this room will get faster with a lighter shoe. 100% of us. Every other characteristic that I mentioned, with shape, with thickness, and with a plate or not, is going to be dependent upon each of an individual. So that's why minimalist is going to come back. Minimal shoes will be back because they are the lightest. And therefore, there will be people who will improve with that characteristic changing. But we are on the other extreme right now. However, light is always something, and actually at the top of our list that we're looking at in terms of materials and foam, pretty much. Carbon's pretty light, but you can't still, once it gets too thick, then again, you're back in the weight issue.
Okay, I think I have only 2 more questions. Sorry, like, Run Nerd can't help myself. But the first is that it's counterintuitive, but most forms of performance enhancement or doping are actually to allow the body to train harder, to take on more training so that you can improve, not necessarily something that makes you superhuman. It's something that allows you to take on more training and to be able to recover faster so that you can take on more training, or so that you can train again with a shorter period of rest so that you can develop all of your systems to perform better. And one thing I've heard, I'm retired, but some of my friends still compete, is that the super shoes also have a kind of performance enhancement in that you can handle more training and you come off of marathons not feeling like you got in a motorcycle wreck, that the shredding of your legs that used to take place, and if you have marathoners in your family, grandpa was a marathoner, he couldn't walk down the stairs the day after a marathon, it's not that bad anymore. So I haven't worn them, I don't know about it, but is that part of the benefit of, is that an unanticipated maybe benefit that we're seeing as well, that you're able to recover more quickly, take on more training and that sort of thing as well?
For sure, because of those characteristics and even the lightness being one, you can train for greater durations or higher speeds in these shoes, even during training. I wouldn't necessarily recommend wearing them as your primary training shoe, but that is a benefit and possibly a detriment. So for sure, it's just being aware of your own training load. But it is we're in a time still, even though it's the first 7 years, that we still don't know everything about them. So there's still risks involved in these innovations. And now everybody's innovating, so it becomes just a little bit more risky, and you have to be more self-aware, and you and your coach be a little bit more thoughtful about these things.
Got it. I don't know if you can share, so don't divulge anything you don't want to.
Trust me, I will not. I love my job.
Are you tinkering around and playing around with applying some of this technology in other sports shoes? Are we going to see an adapted some of the tech from a super shoe in soccer cleats or baseball or tennis or anything like that as well?
Yes, and that's not a secret, so I'm not going to be fired. Absolutely, yes. And even Coco Gauff, she just won the French Open. She has oh yeah, thank you, girl. She is so awesome. And yes, she actually is very involved in the innovation process, loves to understand what's going on inside of the shoe to help her. She's an incredibly aggressive player, especially in the lateral directions. So you can imagine we're thinking about 2 in terms of plates being rails instead of a plate, and helping with some sports that aren't just in the forward direction.
Very cool. Okay, let's pivot to football again, Jason, if you don't mind. So I think we've gotten to the other side of the existential crisis the NFL and football in general was facing when, less than 10 years ago, the NFL admitted, actually, there was, in fact, a direct link between developing CTE and playing football. And if you go back in time to that period, there were big questions around if this game was still going to be around, if people were going to watch. People definitely are still watching. The NFL is the most watched sport in the United States. Now the NFL is trying to go global a little bit belatedly, and so folks are starting to watch outside of the U.S. as well. Participation maybe is declining, but flag is the solution for that. And so we still have concerns about brain health and football, but the game will go on. I think it's pretty clear to say. I think the reason we're on the other side of this is because of the technology. So can you share with us why maybe perhaps you think that crisis might have stimulated an acceleration in technological advancement with helmets? What those changes looked like, what if there's investment pouring in now because there's an admission of a problem? Tell us about what this looked like over the past 8 or so years, please.
Yeah, I think there's two major things that have changed that kind of affected that came out of that really have affected it. And one was from our company as a startup as Visus that really showed that being the first helmet company that actually provided a product that was insanely expensive, and showing that in around 2016, maybe 2015, the most expensive helmet that you could buy was around $385 to $400. Now helmets typically could be at the NFL level anywhere between $1,500 to $1,700 or even more. And I think that's totally reasonable if you think that that's not just to make more profit for a company, but really to sink more research and design into protecting players. And so I think one thing is that that came out of that is basically the reality that we are willing to pay for something that will potentially protect us long-term and short-term. So that's one thing. And the other thing that's really come out of that period is the data and looking at what's happening on the field, whether it be through mouth guard sensors or through multiple cameras at every stadium in our country, measuring speeds of impact and going back and looking at injuries and looking at the speeds and directions of those impacts. And that's driven the future of how we then analyze our product through laboratory protocols. So with those two things, basically being able to sink more research into the product and then having the protocols that can aim us or help direct us at what is effectively a better product has what's really changed the industry. And so the products across the board that are provided to players all the way down through high school and even into youth have been affected by that change. So just like in every sporting goods product, the new unique thing, the super shoe or whatever else starts out at that high end, but it does over periods of time definitely tailor down into it. And football is no different than any other sport. It's definitely a pyramid with, our youth players being by far the vast majority of the players in our country.
Can you talk about what's going on inside of a helmet? So let's say, and I know they may vary by position, let's say I'm a tight end and I like to catch the ball a lot. And my quarterback, unfortunately, likes to throw it to me when I'm cutting across the middle and I'm getting hit from both sides and one of them is blind and I'm not seeing it coming. What kind of helmet would you recommend that I wear, and what happens inside my helmet when I get hit?
Yeah. So there's basically just kind of in the last 5 years to 6 years, basically been position-specific helmets introduced, and our company was in the first, and that was a lineman helmet first. Since then, we've developed also the first quarterback helmet, and then just recently this year, we've launched a wide receiver helmet. So kind of similar to what you're saying, and why are they different? Is begin going back to that data that we're receiving from the NFL about how these different players get impacted at different velocities and different locations. Like you were saying, blindsided, so maybe side upper impacts, which are some of the most dangerous for a player, right? In that experience, wide receiver helmet might need to be actually stiffer than what a lineman helmet would need to have. And the reason why that would be is a lineman might have 2 to 3 times the number of impacts, but at a lot slower velocity. Whereas, the tight end, as an example, you're going to have a significantly less impacts, but you're going to have them at a much higher velocity. So inside that helmet, as you asked, like what's going on, is the whole mechanical structure is all being designed around how can we absorb that impact and slow that acceleration down that you're going to receive when a player is running at you at 20 miles an hour. And that's the challenge, because no helmet is thick enough to really truly do it. So we can just do the best we can, because these players are so big and fast, that we're developing structures that can kind of absorb and crumple or deflect that acceleration that's coming at you.
As the manufacturer of the helmet, do you also make recommendations to the people who are using them about frequency of use? I know there have been a lot of rule changes at varying levels around what should be restricted, so that athletes are less, like the linemen, for example, the rate of, it's a slower velocity, but they're getting a lot of hits, but they're also practicing blocking a lot. Do you make recommendations on use outside of games or anything like that as well?
Are you talking about keeping the product to its top ability, or just their personal use of it?
Both.
Okay, so I guess from the product side, some people may not know this if they weren't involved with football themselves, is that within our country, a reconditioning system is built within football through all levels. Different states require whether it's 1 year or 2 year, but all helmets have to come in for a reconditioning cycle to a certified reconditioner. And during that time, the goal is not to just clean or repaint or maybe replace the face mask, but actually is to analyze the product and look for whether or not the product is still fit to be continued to use. And so during that process, there will be products. So for example, maybe a lineman helmet comes in and, maybe he's in a high school where he's even playing both direction, right? And so he's playing a lot. And there might be some analysis done as that helmet's disassembled and re-put back together that we would then determine, hey, we would recommend that this helmet be replaced.
Very cool. Okay. I'm going to do some kind of more rapid fire questions. The questions will be faster from me. Your responses can be as long as you'd like. We're going to do a little bit of storytelling. Okay, so you're both working on cutting edge technologies and you're at the forefront of your respective industries. Tell me something, if you can, because I know some things you cannot share about, but tell me something you're really excited about that you've been working on, your group has been working on.
All right. So we recently launched a helmet that's 100%, the whole interior of the helmet, more or less, is 3D printed. What I'm excited about is not just the 3D printing, but really the reduction of limit on what we can do as far as exploration into structures that can absorb impact. So you're asking, how do we protect these players better? Well, through these micro lattices that literally an engineer can't even draw anymore because they're so finite that we have to use software to just even create the volume, leave alone no one could ever create them in manufacturing just years ago. But now we actually have a full-blown product that's in the NFL right now that the whole interior is 3D printed. And by doing that, we're able to do structures that we've never been able to even dream about before. And not only do structures that we've never dreamed about before, but we're able to tailor them to specific players, unlike we've been able to do before. And what I'm excited about is I think that kind of mass or very specific customization is just right here in front of us. That would even not just be, are you a quarterback or not, but what type, actually being able to see you in film and determine based on your play style how we could better protect you.
The innovative thing I'm most excited about, and maybe 50% of this room will be as excited as I am, sports bras. There you have it. Yes, it was also one of my favorite parts of the exhibit today to learn about the history of the jog bra. And when I first came to New Balance 2 years ago, we were starting this huge needs analysis with respect to understanding why it's so difficult and how we can do better. And 2 years later, that sports bra is now launching. So very excited about that, and hopefully we're on to, oh, good, thank you. I wish it was me, but I'm looking out for you.
It's a good segue. What is sports innovative technology from the past that you think is underappreciated, so not, you can't use the same one twice, that you think we should have more respect for?
I'm not stumped. It's a chest strap heart rate monitor. I don't think we place enough value on what you can learn from the chest strap. I'm sorry. Wrist devices, ring devices, thigh, arm. It's nothing. You got to literally get to the heart and understand what's going on there in terms of electrical impulses. It's not so comfortable, but if you want the info, there it is.
A little stumped, but I'll pull something out. So I get, for me personally, and that has nothing to do with the football or anything else, but like the invention of hydrofoils for like ferries and boats have been like 30, 40 years ago. And for someone who's a water sports fanatic, just last weekend being in the Columbia River, Oregon Gorge, like riding waves in a river on a hydrofoil is something I think 30 years ago, if you saw someone doing that, you would have thought they were like aliens or something different. And it just like how sports technology has allowed us to like do things we just never have done before and experience things that we've never done before.
Okay, I have a related question, so maybe not something we should have respect for, but an innovative technology in sports from some point in history that was absolutely outrageous and ridiculous, and you appreciate it for its ridiculousness, that had no utility whatsoever, but it's a funny invention.
Go for it.
Pogo stick. I mean, come on. I don't know what the point was other than like breaking out your teeth or maybe something else, but I don't know if anyone made it past 10 or 20 times, but that was a pretty crazy invention for sure.
I have to go to cyclists. Cycling inventions and engineers and designers. Somehow they get away with it, though. I mean, think about those ridiculous time trial helmets that literally go all the way down their back, or they had those socks that had the fins on them. And maybe I'm appreciating them now for their aerodynamic prowess, but honestly, it's so hysterical to see what's coming out next from them.
But it looks great when they walk into a coffee shop with them.
And you must keep it on in the coffee shop. Yeah, it's fast.
Okay, final question for both of you, of course. What is it like to see the things you create out in the wild? What does that feel like to see your products being used?
I have to be honest, I've been at New Balance now for not quite 2 years, and the life cycle of a product from idea to market is 3, so I'm not there yet.
Well, I've been designing things for a long time and had that opportunity quite a bit. And I worked in the snow ski industry for quite a while. And I just think that in general, sport is something that, whether it be a team sport or individual sport, is an opportunity for really, I think, us all to have good mental health. And so the experience of like giving that person an opportunity to remove themselves from the stresses of life is pretty cool. And so to sit on a ski lift and look down at the person next to you and they're just excited to be out there and know that you designed what they're using is a pretty cool experience. And then being in the football world, this country's kind of crazy. You can go out into any bar and see what you designed. So, you kind of can't get away with it, away from it. So instead of constant like, oh yeah, I did that one, it's impossible to get away from. This country's just addicted to it. So.
Awesome. Well, thank you so much, both of you, for answering my questions. But we have more questions to come for you, both online and Zoom. So if you haven't put your questions into the Q&A in Zoom yet, please do so now. And I'll be walking around the room with this mic. Arthur, Eric, would you both come back up here, please? I can get out of space. Sweep. Oh, okay. Do you want?
I'll join you.
Okay. I was gonna do a manual thing.
Thank you. Thank you.
Well, I'll start us off with a question from our online audience. This is from an anonymous viewer who says, for Arthur and anyone else with a viewpoint, could you address the fairness and technological advantage aspects of Tom Brady's Deflategate scandal?
That could be 30 seconds or less.
Wow, that's fabulous. The technology isn't anything real complicated. It had to do with gripping the ball. I think he could have gripped it whether or not it was in any way deflated. So I'm not actually personally convinced that's a real scandal.
Mic drop.
Well, do we have any questions in the room? We can go back and forth. You just want to raise your hands. We'll start over here.
Particular interest in.
Use the mic so people online can hear you.
Greetings. Good presentations here. I have particular interest in media technology in sports. In interaction with the sportsmen, the athletes, and with spectators through media, through high-tech media, and how that also opens various avenues such as VR, virtual reality, or augmented reality, which is actually more appropriate in sports. Ways of spectators enjoying sports, and also ways of spectators becoming more engaged in the sport. Some sports, in particular, have an aging age group. The young people nowadays are computer game literate, and they're more in that kind of immediate interactive capability. How do you see the immediate sports gaming, technology gaming in media affecting sports, and also how sports affect media?
Can I try that one? Yeah. Terrific question, series of questions in there. So I shared the example of Hawkeye during my presentation. And I didn't talk about this, but instant replay is another example of, we think of it as an officiating technology, but they really begin as media technologies. So instant replay occurs for the first time in December 1963. It's the Army-Navy football game. And this hotshot CBS sports producer, he's only like 30 years old. His name was Tony Verna. He figures out, this is tape, right? It's not the digital era. It's like reels of 2-inch magnetic tape. It's like a jukebox-sized tape machine. But he figures out how to insert little beeps onto the tape so that you can mark where the play is. The whole challenge is like marking and finding the play when it's an analog technology, right? So he figures that out, and you get instant replay in 1963. Does anyone want to guess like when the first U.S. league starts using instant replay for actual officiating? It's 1986, the NFL. So that's like a 23-year gap, right? So for most of its life, instant replay in the first 23 years is all about immediate technology. It's like, how can we make a cooler football broadcast, right? And so only then it's like, oh, wow, well, the cool broadcast just showed me that the referee screwed up the call, all right? And so then there was these calls to sort of like use the media technology to improve the officiating. Now, you could argue that sort of time gap shrinks. So Hawkeye, they get the first patent application like 1999. I think the first tests with real cricket matches is like 2001, but they don't start using it for cricket officiating until like 2005. So maybe that gap shrinks from 23 years to 6 years or something like that. But this is a pattern that I think we can say is true of at least officiating technologies. They always begin as like media and entertainment technologies, and then you kind of figure out like, oh, we can actually use this to officiate. Maybe I'll just stop there. There's probably others that have thoughts on that.
Well, I'll say one thing, which is, I mean, I think you're onto a very interesting issue of youth engagement with sport and how does it change among a generation that's grown up, fully digitally integrated. And I guess I'm of the view that physical sports continue to really attract viewership, and the viewership is, of course, where the source of funding is. And so esports kind of took off but seemed to have plateaued. And so there's something missing in the esport where it's missing like that human element in a clearly visible fan base sort of way. So I could be wrong. I could be proven wrong 10 years from now. Maybe, it's entirely VR football and there's no longer football teams. But my sense is that's not what's going to happen. So that's the handoff to you.
A lot safer, though.
What do you think?
I really, being an engineer, I couldn't answer that question. So yeah, sorry. I guess one thing I would say about the kind of the youth and what that the media is bringing it back, maybe not to viewership, but back to the inventorship of the discussion is something that I think we're seeing a lot more of, especially in sports that are not as controlled by regulation. We're seeing really rapid inventorship and improvement in sport much faster because of the fact that people are posting things online. Someone can do a first trick in Hawaii, and before they wake up the next day, someone in Sweden replicated it and did something different. And so the evolution of sport is happening, I think, in a much faster rate because of this media process.
All right, I'll chime in with another of our virtual audience questions. This is also from an anonymous viewer. Should world records include a note to denote the equipment used by athletes when breaking records, given the impact of new technology in sports?
That's a great question. I had never thought. Yes. That would be really interesting. No, I mean, it seems actually like we could get to the point where you begin to do that. It'd be difficult for some sports because the amount of equipment they're wearing is, quite multifaceted. So it might be a bit of infinite regress to like map out every piece of gear that's on their body, who made it, what year vintage is that gear.
But with AI these days, it might just be a photo to be able to then document what it is. I know in World Athletics, in terms of shoes, that data is there. You have to turn in your shoes after the events, and so therefore, that there is that level already. But I don't know what exists in terms of apparel.
I hope there aren't any stinky shoes. That kind of sounds like not so much fun. Do we have another question in the room? Yes? I think we'll start right here.
I sort of have a little bit of a two-parter based on my hats that I wear. So my first hat is I'm a mom of a competitive figure skater. And recently she was really seriously injured, unfortunately, and had a spinal herniation. And so we started looking into technology for skaters that absorb shock. And so recently there's been a new innovation that actually absorbs shock in the blade. So it's this company, Blade Science, and we looked at it. The blades cost $1,000. And so the question I have, my first question, is really around what is the responsibility of the community, the invention community, to ensure that there's equity, right? So if you're talking about fairness in sport, it's all who has access to it. And we know so many folks, sorry, I said skaters automatically, so many athletes around the world, compete in the Olympics, and they're coming from very different places with very different histories that have very different, and I think you alluded to this, access to this technology. So what responsibility do we have? And then my second question is around youth in sports, and just thinking that, when you have access to sports, like you said, the people that are coming up with these inventions tend to be athletes themselves. And so what opportunities do we have, and are there any programs at any of your companies to work with youth that have really inventive mindsets? So I work at a youth museum in Makerspace, and we have an invention challenge. And so really thinking, how do we get our youth who are already doing these sports to start thinking like the adults on this panel?
So let me take a first stab at the first question. You guys are much better positioned for the second. And actually, others may want to answer this too, because you may not agree with me. So when it comes to elite competitive sport, I'm of the viewpoint that, the competition will be much more interesting if people from whatever country they're from, whatever league they're from, have quite equitable access to the same technology. That poses a challenge because, of course, national teams sign deals with equipment manufacturers. And so, if Speedo's cut a deal with U.S. Swimming, then, yeah, exactly. Ecuador's swimming team may not get the same thing. So something needs to be rethought there in that sense. The bigger question you're asking is actually one that's very fundamental to how we think about new technology in our country and internationally, which is, what is equitable access to a new product? And if we don't allow differential pricing, if we don't have a system where being an innovator means you get a reward in the marketplace, there's very good reason to think we won't have the next wave of innovations. That poses actually a really an ethical conundrum, which is that means some people who are richer get it first. And then over time, in our patent systems designed around this, the patent expires and it becomes, very cheap to copy that technology. Now, also because of the incentive, other firms can re-engineer it and do something a little different, hopefully even better, and get the reward. So, ideally we have a very competitive space, and we're hearing that, right? So the shoe technology is accelerating, and Nike had a bit of an edge, but now it sounds like New Balance is right there. And maybe I'm even wrong about Nike even having had an edge a couple of years ago, but right, they certainly had a marketing edge. But so, that works out in the innovation, but it still doesn't get the technology to the youth who's been injured, who really ought to have it. And so that we need to find other ways of doing.
Well, I was just curious if, to kind of repeat part of the question is, do your firms have programs that kind of subsidize that or try to create that kind of access? Just kind of amplifying the question. Or have you guys thought about that kind of thing?
Yes, both. I worked for Wahoo Fitness prior to this, which is a cycling company, and now New Balance, and they both do have programs in terms of shoe donations, shoes that you can imagine that are not being sold, that can be donated, that are the highly technologically advanced ones. And I think it is a company I feel does give back in terms of the community. It's just hard for me being part of a bigger group, because if it were me, honestly, I owned a fitness company, I didn't make a dime, because I was like, everybody come, be happy, work out. So yeah, I'm the worst person to ask, because I think it should be for all.
Yeah, same thing. It's an obvious thing for football players across our country. We want to be able to provide the technology that a $20 million quarterback in the NFL has for a 14-year-old also. And so that's really a challenge for us, is that what can we learn from these more expensive, unique, 2,000 players in the NFL that we can then bring down and push into there. So we do that through two ways. One is learning from that technology and how we could provide it to those other players. But the secondarily is just working within our company on finding high school teams or youth teams that can afford good product. And then how can we partner with someone, whether it be within the community, whether it be an NFL player maybe in that area that wants to give back to their team. But that's something that we look for all the time, and we're constantly doing. Obviously, someone in the development side doesn't totally know each one of those, but that happens readily with Certor Sports.
All right, we'll circle back to a question from our online audience. An anonymous viewer asks, how do you address the biomechanical differences between men and women in footwear? As far as I know, most female shoes are still based on males.
Now that I can speak to for New Balance, specifically the research lab. About a year ago, we started a women's initiative that we would get to the place of 50% of our research studies are women, 50% of the molds and lasts that we did for our prototypes, our women. Now, with that, I've learned so much along the way. Basically, there just needs to be more variability in heel and forefoot widths. It's a misnomer that women have more narrow feet. To be honest, we have typically, and that's only 60% typically, women have more narrow heels and wider forefeet. So it can't just be men and women's. We just need to be more individual. And I would say that across the board in footwear as well as apparel, and think more along those lines, other than sports bras.
Wonderful. Do we have another question in the room? I think we've got one back there, and then we'll come up here.
Well, I'd like to thank our authors and to thank our panel for taking on this area of invention, innovation, and the remarkably exciting work that's taking place. I have a question. I think it's really for Jason, but I'd invite anyone to answer. Jason, you talk about the data that these helmets can gather, but you also talk about donating potentially equipment to school districts. I seem to recall in the last year or two here in our local community, one equipment apparel company was going to very graciously donate to an entire school district helmets for all players on all teams, and the school district ultimately turned it down. And I'm sure there was a lot more to the story than we heard in the media, but it rose to a concern over who was going to collect the data, who was going to own the data. So I'm curious from your perspective, when you have these helmets and they're used by a high school or a college or a professional team, do you still control and gather that data? Or once the helmets go out, does the data belong to that team? I'm just not sure how it all works.
Yeah, good question. So our particular company does not have data acquisition within our product. There are products out there that do. We've, finding out, like receiving data about a particular player and then maybe determining whether or not they're safe to play the next game or in the next play, brings up a lot of questions. Does the coach want to know that? Does the parent want to know that? Are there false positives or false negatives? So there's a lot of challenges there, and adding those costs into the product. And then one of the biggest challenges that we've seen from those types of products is who mans it. When you have a small high school or a youth team, is a parent manning some sort of a system that's telling him that, John needs to come out before the next play? It's very challenging. And so I guess we've taken the mandate ourselves is that we want to try to create product that actually protects players, doesn't identify whether or not they were injured, but more focuses all of our research and design into protecting players. So we put that extra dollar into actually further exploration of impact structures and absorbing the impact. But beyond that, at the high levels all the way down, there's a lot of data being collected that's not specific to player, but just for us as an industry to just learn about. And some of that most valuable is coming from mouth guards right now. So where they're putting accelerometers, hard to say, into mouth guards. And it's something that's kind of maybe not intuitive to think about, but if you can imagine, you're concerned about what's going on actually with your physical head, not with what the helmet's doing. So a helmet moving around very quickly could show extreme accelerations, but it's supposed to, right? It's supposed to be moving and protecting you. What we're really concerned about is what's happening to your actual body. And so the mouth guards and those accelerometers in those mouth guards is a pretty unique invention in that way because it's connected directly to your jaw. And that information is super important for us as a designer because it can tell us at the youth level or at the high school level or at the NFL and D1 level, what speeds are these players actually reaching as far as an impacts? And therefore, in our lab, what should we be testing the products to, right? If we're designing a product for a D1 athlete and giving it to a youth league, that's probably not apples and oranges as far as their speeds. So that's kind of where that data has kind of come into the lab, into our product eventually.
Wonderful. I believe the gentleman here in the second row has a question.
Yeah, I was curious about, I was a skier, and I'm also thinking about things like NASCAR, where this bootstrapping between the athlete and the technology is changing the sport, and the generation of the technology is faster than the generation of the athletes. I'm just curious, what do the companies think about how trustworthy the system is for making the right balance between those two things? And how much should we be trusting that kind of governance of the balance?
Leave it for a moment. Can you explain a little bit? I'm trying to understand what you mean by the balance between.
Well, because I'm just thinking, for example, I remember my hero was Jean-Claude Keely. Okay. And it was the edges that he had on his skis that everybody then in the next generation, everybody's doing that. Then parabolic skis, then, right? So there's been an incremental increase in the quality of the ski itself, the bindings, the boots. Everything has changed very dramatically in skiing. For sure. And yet we still think that it's the athletes. I mean, Lindsey Vonn and Michaela Schifrin are still national heroes, right? So the athlete is still really important. But what I don't know is, have we got the right balance between the athlete and the equipment? And is it that they have really good corporate relations with a particular manufacturer that allows them to stay at the top of their game? Or is it fair?
Yeah, I mean, I don't know it's fair, but I think, for what I care about almost more than like the Lindsey Vonn is that general athlete and that person that's going out on the weekend, because that's the one who's actually paying our salaries. And not only just do I care about them, but I want them to have fun out there. And I think that our job as inventors or developers is to provide product that can just make it more enjoyable. My dad's 86 and skis 20 days a year. And he can only do that because of he started in leather boots. He can only do that because of the products that we provide to them. So, I really believe in, how can we give more opportunities for people to get away from their computer and just outside and doing something. But it kind of goes back to the question about, they got a world record because maybe they had, different skis or different product in that way. And it's a good question. And I think the challenge there is, how do you compare people nowadays versus 20 years ago? But I think that the interesting part there from athletes is they're having to constantly change maybe their skill as these products change. And so maybe the best comparison is what's happening today and who's the best at a particular sport today.
And just to pick up on that, I mean, I think there's a very interesting dynamic between sort of innovation in technique and innovation in technology, because Jason's right that even in skiing, the technology matters a lot, but also how people ski, how they train keeps changing. And in certain endurance sports, for example, we have, in a way, a dilemma, which is, okay, we say you're not allowed to take performance-enhancing drugs, but we have no objection to you training at altitude and changing your body's biochemistry by training at altitude. And so some of these issues really are still wide open for adjudicating fairness and finding some sort of balance. I was particularly interested that, these sports leagues have been thrust into acting like regulatory bodies, but without the preparation that a government agency has to do that in terms of being sort of predictable, in terms of having routinized ways of evaluating technology. And so they've been forced to build that into their systems. Turns out regulation's expensive, right? It takes people, it takes a whole lot of effort. But on the other hand, it will provide a baseline for the manufacturers, for the technology developers, for the independent inventors as well, to know, these are the folks who are going to evaluate it. Here are the metrics they're going to use. Now I have some parameters within which to invent. And so I guess I'm of the advocate of saying we need more transparency in that mode of oversight in order for the innovation pipeline to keep going.
can I quickly make a film recommendation? It's probably a film you've seen, is my guess, but a documentary film, award-winning, that I think touches on all of these themes is called The Crash Reel, and it's the story of Kevin Pierce, who was a peer of Shaun White. So if you don't know the name Kevin Pierce, you would have known it on the par of Shaun White had he not had a TBI, a traumatic brain injury. And the film, he's a snowboarder, half-pipe snowboarder, and the film gets into basically like these half-pipes, like you keep the one-upmanship and forever improvement in the heights that you reach on the half-pipe, et cetera. And the companies were incentivized to make steeper half-pipes so that the athletes could go higher to do more tricks because it's never-ending, and it crossed that threshold. And so Kevin Pierce fortunately survived, and his he wonderfully loved. Shouldn't tell the whole plot of the movie, but it's really, really good, and I recommend it. And you'll fall in love with Kevin Pierce, who has a foundation now called Love Your Brain. So,
What was the name of it again?
The Crash Reel.
Lovely. And with that, we are right at the 5:30 mark. So that was beautiful. Thank you so much for everyone for coming. We got one more question.
One more question.
One more real quick question. And then we'll release you for food, I promise.
Thank you. Do you have any advice for current engineering and design students aspiring to enter this industry and invent for sports?
That's all you guys.
Yeah. I'll take that first and I'll let you. I can't say enough about getting involved in whatever you're passionate about, whatever sport it is or whatever gets you excited to be in that. And for me, I've hired a lot of engineers over the years for a lot of different companies and different product designs. And what I look the most for in those scenarios are people who have gone out and done it on their own. They've built a skateboard in their garage, or they've tried to do something on their own, and that just really gives us a feeling that you're entrepreneurial, you're going to go on your own and do something. And so I would really encourage you, if there's a particular sport or design type that you're interested in, start sketching it, start looking at how you could actually design something yourself. That way, when you do go talk to someone that is maybe your dream job, you're not just a smart person, but you've actually kind of shown action at that.
I could not have said it better. And it's now been me being in the industry, either academically in these same types of people in engineering and sport, but it's that passion, and it's that showing that you would do something crazy a little, whether it's put flour on the track or to find that answer. And for sure, just don't give up on it, because it's really hard and there aren't as many, but if you keep up at it, go for it. And also the small opportunities, the internships, the going to events like this and meeting people. I think you never know what little nugget you'll get or opportunity. Good luck.
Wonderful. That's a fantastic way to end. And we will wish you all the best of luck. And thank you all for coming, and ask that you join us in the atrium for drinks and refreshments. Thank you again.
Just going to do a group photo. Terrific. That was great. Thank you so much. Thanks for having us.
Oh,